All right, we'll go ahead and get started. So thank you for joining AKS office hours this week. My name is Dave Strebel. I am a cloud native architect on the Azure Global Black Belt team. Essentially, our team, we have a really cool name, but really what our role is, we have much narrower focus in Azure. And a lot of our team focuses around the cloud native space. So things like Kubernetes and kind of the open source ecosystem around it. Kendall Roden will not be here today. She was not feeling well. So she will be absent this week. So, just for anyone new, kind of why we have AKS office hours is really to provide you with updates pertaining to AKS, but also anything really in the cloud native ecosystem. So sometimes we will present on other things outside of AKS that kind of pertain to the cloud native ecosystem. Typically, we hold a short talk, or which usually includes a demo on cloud native technologies related to Kubernetes and AKS. This is also a time to that we like to, really get your feedback from, issues, blockers that you're having, use cases, and really just any of those general questions related to AKS or running Kubernetes in Azure. So always feel free during the, kind of the presentation. You probably want to stay on mute, but feel free to use the chat. We have others from within Microsoft, others from my team. Sometimes we have product members that join, so feel free to use that chat along the way. And we will typically make sure we have time at the end to do more of a Q&A just on, not the presentation or demo, but just a general Q&A. What to expect? And I forgot to update this again. Today we are going to be talking about the Open Service Mesh add-on for AKS that was recently released in preview. We talked previously on service meshes in general and kind of did a quick overview of Linkerd. Today we'll be focusing around the open service mesh. So some of the information may be a little redundant of what we had last time, but I think it's still good to have the context when we start talking about service meshes. Then we'll leave, typically we say 20 to 30 minutes, but a lot of times we go over just, talking through this. But again, use that chat. Like I said, we have a lot of people on the team that have a lot of experience that are on the call to help with the, questions you may have along the way. Keep in mind, we really want this to be a two-way interaction. So, speak up, ask questions. If you're not used to Teams, there's a nice little like button at the top where you can like raise your hand. If you don't, want to, kind of interrupt, you can use the hand. I'm fine with the interrupting too. But we want to make sure that it's a two-way interaction and more of a discussion. This call really, how it's conducted and how it evolves and the topics we choose is typically any of people that join. It's your call. We want you to get the value out of it. So we love to have feedback from you on like what's working, what's not working, what topics you would like to see. If you want to present on a topic, that would be even better. One of the things we will be doing is host all the information in a GitHub repo. We'll be using the issues in the GitHub repo for suggestions, topics, or if you want to present those type of things. We're open to a lot of different topics. It doesn't just have to be on AKS. For example, if you had a talk you want to do on something like Prometheus, that would be awesome. So feel free to reach out to us. Usually the email's at the bottom here. I must cut it off. It's aksofficehours@microsoft.com. I'll put it in the chat window. But that will go directly to myself and Kindle if you want to be more anonymous than putting stuff in the GitHub issues repo. All right, so AKS updates. So a few of the AKS updates, the CSI driver will become the default for Kubernetes versions 1.21 and over. Automatic node image update is in preview. So if you're running AKS today, a lot of you may run something like Cured to automate those kernel reboot or those kernel patches to do the reboots for that. Now you can do automatic node image updates, so you can opt into that. It will follow. There's also a feature where you can set preferred maintenance times. So if you want, on a Sunday from 12 a.m. to 6 a.m. For those maintenance things, it will follow that schedule. So you can opt into that automatic node image update today. That is in preview. That updates your node images. There's also where you can opt in to update your Kubernetes versions too. They'll do automatic updates. And you opt into kind of a channel. There's a stable, there's a preview channel. I think there's one other there, but it'll essentially give you if you opt into that preview channel, it's going to give you the newest release every time it comes out. So anytime a new, like 1.20 was in preview, it would have pushed you to that release. So obviously you don't want to opt in to that for production, but the stable channel will give you like N-1 on there. So it gives you what we consider the stable version in AKS. OSM add-on, which we'll be talking about today, was just released in preview. I believe last week it was. Might have been the week before. But also something to try out there. PSP deprecation. So we talked about this before. As opposed to retire, we were retiring that or deprecating that in June of 2021. Due to the upstream deprecating PSP from Kubernetes. So we will be following more of the upstream guidance here and be deprecating PSP with 1.21. And it will be fully removed in Kubernetes 1.25. There is a enhancements proposal to replace PSP with something very similar. One of the ways that you can do it in Azure today is you can use Azure Policy for Kubernetes, which uses Open Policy Gatekeeper to implement those same type of features that you would get out of a PSP. So you kind of need to decide how you want to do that. Like I mentioned, PSP is being deprecated, so I wouldn't put too much effort into it because it is a very hard API to work with. So I would not really go down that path of continuing trying to work out that strategy when it's going to be deprecated and fully removed in 1.25. I will try to find the link, though, that has a enhancement proposal for kind of the new version of what would replace PSP within upstream Kubernetes. Kind of a quick upstream look ahead. There's going to be a bunch of, again, if you've gone through a release of like 1.15 to 1.16, I believe it was. I could be off on my numbers there, but there was a big change in a lot of the API versions being deprecated. This V1 beta one, it's kind of where in Kubernetes, a lot of times there's APIs that are in beta, but we still use them. Because they've been around a long time. They're very stable APIs. They just may not be feature complete, is why they're still in beta. And typically what happens is when somebody wants to go deploy something in Kubernetes, they search the internet, they pull something that's using old APIs. So you may have a lot of these V1, Beta 1 APIs around for your deployments. So that will be something that you will need to look at when you're moving to 1.22. Currently in AKS 1.20 is in GA, and 1.21 will be coming preview, and then 1.22 is the next release Kubernetes upstream is working on right now. So you will be needing to refactor your YAML files again. There's some cool tools out there, Open Policy Agent being one that you can use to validate your YAML files. You can do this, whenever you go through like a mission control, when somebody submits their manifest, you could block that. It could detect that. One of the better ways to do this is in your CI pipeline, you can use a tool like conft, which is part of Open Policy Agent, that essentially just links those YAML files to say, hey, we got a tag for this v1 beta 1, so reject that, and pass back useful information to the end user, like, hey, don't use v1 beta 1, use this API version instead. Ecosystem updates. A few here. Argo CD 2.0 and Argo Workflows 3.0 were released. If you're not familiar with Argo CD, it provides a GitOps tooling, and it kind of works in both ways. It provides that pull mechanism, but also you can base it like on a push mechanism. The 2.0 release had some enhancements to the UI. Also, they have a feature called like application sets in there, which is for kind of multi-cluster deployments, where you can sync up that single Git repository to and create an application set that will be deployed to multiple clusters that you define in there. So those I believe they went to a stable API in Argo CD 2.0. For Argo workflows, it went 3.0. A lot of different usability enhancements there too, especially from the UI. For Pulumi, if you're not familiar with Pulumi, it's another tool like Terraform, but it lets you define your kind of infrastructure as code in actually a real language instead of something like HCL that Terraform uses. So you can use things like Go, Python, TypeScript, JavaScript, all those good ones that you typically may use out there. It just had its 3.0 release. They have a lot of stuff going on with their native providers. So the one for Azure went GA, the GCP one went beta. Just also some improved SDKs for their Python and Go implementation. They also introduced a CI/CD assistant. So setting up CI/CD pipelines for Pulumi. It has essentially the easy button for that to walk you through of what you would need to do for that. I didn't play around with it. I just kind of looked at it, looked kind of cool. So definitely check Pulumi out if you've never used it. It is a really nice tool compared to, I think everybody is probably familiar with Terraform and may love or may hate it, but definitely check out Pulumi. KubeCon EU will be coming May 4th through the 7th. So it will be a virtual event again. The nice thing about being a virtual event is it's very cheap. It's $75 for the all access pass. The one thing they did change, before they used to put up all the sessions like right away, you would have them within a day or two. Now with the virtual events, they wait, it seems like almost a month. So if you do want like instant access to those, I would just pay the $75. You probably can find coupons out there too on like the Twitters or something, but definitely check that out. I think one of the cool things that I would really look at that I've always thought was really good was the co-located events. And you'll see some of the ones that have been doing events like there's a PromCon. Try to tell you like your, significant other you're going to PromCon without, with the straight face. It's pretty difficult. But all these different events or co-located events are usually like single day events. Some of them are totally free. Some of them are very low cost, where they're like $50 or $100. But a lot of those even donated to some organization also. I would definitely check out those co-located events. There's a few cool ones I saw where essentially all day is you try to hack a Kubernetes cluster. There's a lot of different security ones, a lot of different monitoring ones, like there's a new one this year for, there's a GitOps con. So definitely a lot of good co-located events also for that. Another tool that I was looking at was Kubesploit by CyberArk. So essentially, it's a cross-platform post-exploitation tool dedicated for containerized workloads. So you can do a lot of different, like breaking out from containers in it. It's kind of like a Metasploit, but not as fledged as Metasploit, but it allows you to perform a lot of these different common attacks. Another note, Open Policy Agent moved to a graduated status in the CNCF. If you're not familiar with that, the status is essentially when you move to like a graduate status, there's not a lot of the projects in the CNCF that are in a graduated state. It typically means that there's been a lot of adoption of that solution, or there's usually it's based mostly on the adoption rate of it and success of the project. There's some other criteria can go into it, but majority is based on how well adopted that project has been. All right, so we're going to jump right into open service mesh. So kind of what I'll cover here real quick will be, what is, why, and how of service mesh. We'll talk about the open service mesh slash OSM add-on for AKS, how you can enable that, and we'll go through a couple different scenarios with that in the demo, and then we'll leave time at the end of this meeting for open Q&A. So what is service mesh? So if we look at service mesh, it really decouples like from the application a lot of these operational capabilities. That moves them out of the application layer. So if you think of stuff like how your application teams are having to maintain like doing MTLS between service to service, they're having to write a lot of like glue code. They're having to, you're having to maintain a lot of these different libraries, especially if you're in a more polyglot language environment where you have developers that are writing JavaScript, they're writing .NET, Java, all these different type of languages. You have to start maintaining all this kind of glue code. Service mesh takes that down and makes it essentially an infrastructure capability. So you can do things like encryption of your east to west traffic. So doing mutual TLS between service to service within your cluster. Some of the traffic management features. So things being able to do canary and phased rollouts, blue-green type of deployments where I could do a lot of the traffic shifting capabilities that I may need, where, I want to V1, I need going to send 75% of the traffic, and to V2 of my application, I'm going to send 25% of that traffic. We can also control a lot of the traffic through policy. So we can say, hey, service A can talk to service B on this specific port and this specific path. So it has a lot of security features, and I think that's where we typically see customers first adopting service meshes is for one I typically always see is a requirement for mutual TLS. That is typically the first one. But observability is a big thing too. Being able to gain some of that insight into how all your services are connected up and their traffic flows. This becomes much tougher when you move to like a microservice architecture because now you have a lot of different calls between different services. Networking really changes in that, and you really need to have the observability of how those services are connected up and the different traffic flows and that. So that is typically another reason why customers adopt service meshes. If we kind of just look at how a typical service mesh, kind of the architecture, is you essentially have this control plane, and this control plane sends out configuration to these proxy sidecars. So when you spin up your application and you enable it to be part of that service mesh, it will then inject a sidecar proxy. In the case of open service mesh, it uses Envoy as its proxy. So the control plane will send configuration data. These may be like certificates. It may be policy information to these different proxies. And how each of your service talks to each other is through these different proxies. So the biggest question is, when do I need a service mesh? I always say, if you're asking if you need a service mesh, you probably don't need a service mesh, uh, and that's more tongue in cheek there. But uh, when you start looking at service mesh, one of the big thing is, are all your applications written in one language? I talked about all kind of this kind of utility code that you may have to write when you have to start maintaining a lot of that utility code between different languages and maintaining those libraries. That can become a lot to maintain. Do you have dedicated engineers to build that actual kind of tooling and instrumentation for your applications? Because if you don't, that's something you should really think about. Service mesh can really help automate some of this and have some of that just built in out of the box. Is your application a total monolithic application versus a microservice architecture? All these things really kind of go into when you need to decide is what the trade-offs are there. And I will discuss some of those different trade-offs when you do go down this path of implementing a service mesh. So when you do have those microservices that are written in multiple different languages, that's a lot of times a good sign to start thinking about service mesh and what the value of it can provide. And those different features like MTLS out of the box, those type of things that you can be a quick win for you. We talked about, the utility code. Are you writing utility code to do things like cert rotation and all that? Where are your teams spending most of their time? Or is it fixing the application? Do you have the observability you need for your architecture? All these things should really be thought of before you decide to take on that service mesh, because with service mesh does come some complexity. Because you are introducing these new proxies into your data plane. So you have to be very comfortable in troubleshooting a service mesh. You have to have some expertise in Kubernetes. You have to have expertise in networking and the service mesh solution you're going to implement. So you have to be very comfortable with that. The one thing I see a lot customers adopt it uh, prematurely is they're not really all that comfortable with Kubernetes yet and running Kubernetes in production, but they've already decided that they want to implement a service mesh. That can just be a cognitive overload, especially if you don't have like a dedicated team. I've seen for some of these service meshes like Istio, a customer that has it in full production. It's a large environment, but they have a dedicated team that just manages their service mesh. So you have to think of like what that cognitive overload and just operational responsibility is going to be, and be comfortable with, how those Kubernetes operates with that service mesh. It can also have a performance impact because you are introducing these proxies. Some of the service meshes, like I say, Linkerd that we talked about last time, has less of the impact. They wrote their own proxy, so it was super fast. I wrote in Rust, really to minimize that impact. Envoy has gotten much better over time, but there can be a performance impact, so just be aware of that. And the cost of service mesh. A lot of times we see these open source projects, we see them as free. They're very easy to install. It's like home install XYZ service mesh, and now I have a service mesh. But that's not free, because now in your applications, you're injecting a resource into every application. You inject a proxy into every resource. So even when you decide to go with service mesh, doesn't mean every application that lives in Kubernetes needs to be a part of your service mesh, because there is a cost to that. Just not an operational cost, but a resource compute consumption cost to it also. So open service mesh. When I say work in progress, I should update this because it's actually, they released, I believe yesterday, .8.2, I believe. I also already mentioned it utilizes Envoy proxy, so it has a control plane that will then essentially inject that that proxy for any. You can base it like you'll see in the demo that we'll go through that we enable it on the namespace. So anything in that namespace gets its pod gets injected with that Envoy proxy. Some of the areas that it's been focused on currently is I think the key capabilities of why customers are adopting a service mesh is really enabling MTLS out of the box. I always say that's kind of the first one I always hear when somebody gives a reason of why they want service mesh. Then also having those fine-grained access control policies. In the demo, we'll go through one of those showing those kind of access policies that you can set and how those work. Then observability insights into application metrics for debugging and monitoring services. So it emits Prometheus metrics, so you can get detailed metrics on latency between service to service, those type of things to get a better observability into those metrics. It can integrate also with. It has a internal certificate management solution it can use. But it can also integrate with other certificate management services. I believe right now it integrates with HashiCorp Vault, Azure Key Vault, and then also Cert Manager. So it has a interface for these so others can start plugging into Open Service Mesh. It also contains traffic shifting capabilities. So it uses a traffic split where I can, do a traffic split and say, hey, I want 75% of my traffic to version 1, and then 25% of that traffic to version 2. This is how it implements these different solutions here is through the service mesh interface. If you're not familiar with SMI, service mesh interface was kind of there to create a standardized specification for service meshes. I don't know if it's really totally achieved that. We use it in OSM, but there are others that do use the SMI interface to get like traffic splitting capabilities. For example, Linkerd that we showed off before, it actually uses SMI for its traffic split. You could use SMI with Istio. I don't think I would ever recommend that, or I don't think a customer would, because now you are kind of held to what the limits of like the service mesh interface and the features that it implements, and not getting the full capabilities out of something like Istio. I think it's great if people want to use it. I wouldn't base decisions on a service mesh based on the SMI spec, is kind of what I'm saying. All right, so a couple different demos scenario. We'll go through, we'll deploy an application without enabling it for service mesh. So essentially we have a book buyer and a book thief. So this will, essentially it's going to order books, and then we're going to have this book thief who steals all my books from the book warehouse. Then we'll implement the service mesh, and then we will build a policy to say what services can talk to what services to show how those different policies will work. In the second demo scenario, we will use the traffic splitting capability that we can do within OSM. All right, so let me change my share screen here. Did anybody ever know that Wayne here, like, had a Washburn? I never realized that. I thought he always had a fender. There may be some people too young to remember Wayne's World on here too. Let's see. All right. Let's see. Let me zoom in a little here. All right. So essentially what I've done so far, all I've done is I have a cluster. It's enabled for OSM. I use the OSM add-on. If you want to create a cluster, you can. If you already have a cluster created with AKS, you can just go in and do the AZ AKS enable add-ons and specify OSM as one of those add-ons, or you can do it deployment time. I did mine at deployment time. When you look at what gets deployed, you'll see just a couple things in the kube system namespace here. The OSM controller, so that's the control plane of OSM. That's what's going to contain the configuration for our proxies. It's going to contain configuration for policies, our traffic splitting, all of that good stuff. We then have this OSM injector. The OSM injector is essentially a emission controller webhook that will then see that our, say, for example, in our case, we're going to do it on the namespace, that, hey, this namespace is enabled for OSM, so any pod that gets deployed, I need to inject this Envoy proxy into. So currently in here, I have the book buyer, the bookstore. These are all pretty just typical deployments. I don't want to necessarily go through these all. Just they have a service, they have a deployment, they have a service account. Book thief, book warehouse. These are the 4 things that we'll really be deploying here.
Can you increase the screen for your visual code, please?
Did you say zoom the screen some more?
Just make it full screen. It's kind of hard to follow. Yeah, perfect. Thank you.
All right, perfect. All right, so now that I have my namespaces, I did put some of these out so you don't have to watch me fumble around with misspellings and that. So here, I'm actually, you know what, I'm not going to follow that. I'm going to first apply everything without the OSM namespace here. Or actually, we'll do this. We're going to do the namespace first. So we're going to do OSM. I'm going to enable it for no namespace here first. We'll do that. So here is all the namespaces I created. And essentially, I just enabled these namespaces for adding those to be part of the mesh here. So now I'm going to deploy all these applications. So I'll do a kapply dash. All right, so we have our resources created now. So one of the things I'm going to do here is do a port forward so I can show the application. I'm not going to do it from that screen. We'll choose something else here. All right. So we have the book buyer, and we're going to do the book thief also here. Sorry about that. Thief. Here we come. All right, so. And sorry, you probably will hear a barking dog in the background. All right, so we have our book buyer application. I have no book buyers yet. Oh, I know why. We don't have a SMI policy here. So right now, if we look at our SMI config, this was something I probably should have had changed, but we'll still show it. There is a permissive traffic mode. If this permissive, by default, it is set to true. So when I deployed it with AKS, this traffic policy mode was set to true. So meaning that anything that is part of the service mesh. So all these are part of the service mesh because they got deployed to their namespaces that were enabled for OSM. They can all talk to each other. if I update this config map like I already have and set this to false, that's going to say follow the SMI traffic policies. So let's look at a SMI traffic policy. My access policy here is going to say, here's my traffic target for bookstore, this using this service account, this HTTP route group. So it's going to do like a match, kind of like a label selector on this match. As you can see that we create this HTTP route group, and it's saying this books bot that we said that this can talk to, that it could match here, is going to be the path that it can match and perform a get on is books-bot. And here we can also pass in some different headers in that. Buy a book is it's going to use a regex path here for anything a-book here. And it's going to allow a get method. For the update books bot, it's going to perform a post. It's not allowed to, on that path there, it can't perform any other action except that post. Same thing down here. This is just using a different traffic target for our V2 that we don't have yet implemented, but this is how you set these policies. So you have to remember, if you have this set to false, everything's going to be denied by default. You have to create the traffic targets and the HTTP route groups to enable communication from those different services. So what we should have seen here is that you would have saw a bunch of books being bought here. And then on our thief one, you would have saw it stealing a bunch of books. Reason it didn't, because I never changed my policy mode back to true. So the only difference here you would have saw in V1, this would it all been the same. It'd been like 120 by now of books bought, books stolen. So now if we go and implement this SMI access policy, and it is SMI-access. All right. So it created those different service or created those different HTTP route groups and our traffic targets. Now what we should see, if everything does go well, is the book thief should still stay at 0, but my books bought, now you can see the traffic flowing, that orders are going through from my bookstore, but you should see, because all we allowed was the book buy. We did not allow the book thief anymore, so its access got cut off. So that allowed us to segment that traffic so it could only, this service could only talk to it, rather than everything within the mesh. All right, now that we have that going, we already patched. One of the things we want to do is also do a traffic split. So currently, as you see, we have a V1, V2. This V1, V2, we see V2 has 0 orders here. So if we do get bookstore, okay, perfect. Just want to make sure that is running. We are going to apply this SMI split here. Where to go? This SMI split here, I've kind of combined these things. So the deployment for the V2 here. But what we're looking at from here for the split, the traffic split, is the configuration we're looking at. So it's going to target a specific namespace, and it's saying the backend service for bookstore. So is our V1, which is going to be 20, the weight is going to be 25%, and to our bookstore V2, which is going to be our new deployment in here, is going to be 75%. So split. All right, if all goes to plan, Okay, now we see V2 is starting to get more traffic. So quick and easy. So what you got out of just doing this is that you now have MTLS between service to service. You also have traffic policies that you can set. So I can limit what service, each of those different services can talk to, what paths they can talk in, what actions they can perform. So can they do a get or post? And I also got traffic splitting capabilities out of this. Very easy to implement once it goes, GA within AKS will be fully supported by Azure support. So you get a lot of these great pieces out of the box. The one that I didn't have fully set up for specific reasons was the Prometheus stuff. There is a Prometheus that the one you would have to use your own Prometheus. This will also be integrated into Azure Monitor for container insights to be able to pull a lot of these metrics. So things like latency off like your service to service communication. For the Prometheus, if you want to integrate Prometheus with it, you definitely can do that. You would have to deploy your own Prometheus server and use Grafana for the graphing capabilities in that. There is a open service mesh Grafana dashboard that you can easily deploy. It's within the Grafana Labs in their kind of marketplace. So you just put in the ID of it and it will build that dashboard out for you. You just got to get Prometheus hooked up to it. All right, we're at 15 minutes till, so I'm going to stop there so we can leave time for discussion. For the discussion, we can anything that you have questions on, whether it's open service mesh or you want to go outside the bounds of open service mesh, I'm totally fine with. We have a lot of people on our call that can answer questions, so definitely, if you just want to raise your hand on here, we can do it that way. Or if you want to come off mute, do that too. Maybe I should check the chat too.
Hello.
Hello. What question do you have today?
How does this relate to Calico?
Good question. So the difference when you look at service mesh and how it implements a kind of network traffic policy is it does layer 7 traffic policy, where Calico is just doing a layer 4 type policy. That's the main difference between them. Because Calico is not, they're advanced. I think Calico in their enterprise paid version does have some of the layer 7 type policies, but typically in a service mesh, it's implementing its network policies at layer 7 at the application layer. And did that answer your question? I should have made sure first.
Okay, do I even need Calico if I'm going to use OSM? Can I turn it off?
Yeah, you don't necessarily need it if you want to implement those policies. If you're implementing the policies at layer 7.
Okay, thank you.
I have a related question to on the same topic.
Sure.
So would OSM like make it from and I'm coming from a purely operational perspective, make it more easier to operate, say, instead of having to look after Nginx versions and the 3 different kinds of Nginx, which are all called Nginx, instead of trying to keep track of the various Nginx images and trying to figure out which version of AKS will support the latest version of Calico, would this open service mesh, I know it uses Envoy, but would you have to like if if you just update Open Service Mesh, would it automatically take care of the Envoy upgrades? That is one. And if your requirement is just to do basic micro segmentation across namespaces, because external firewalls don't have much visibility into what's going on within Kubernetes, if all you have to do is just regulate, deny all namespace to namespace traffic, except if it originates from kube system, allow everything that's going to and from kube system from any namespace, regulate namespace to namespace traffic, and have MTLS. Would the Open Service Mesh be like a good alternative to having to maintain, say, Nginx, Calico, and another service mesh like Linkerd separately?
So there's a lot of questions in that one. So I'll start with the ingress piece. Open Service Mesh does not provide a ingress. So Open Service Mesh is focused on the east to west traffic. So the mesh is part of the actual cluster. It doesn't have a ingress controller today. So you would still need something like Nginx. You would set it to pass its headers. So when it goes into the service mesh, it can do tracing in that, but you still need a ingress controller with Open Service Mesh today. Just like Linkerd, they're not a ingress. They don't care as much about north to south type traffic. It's that east to west traffic that they care about and implement. I think the only one today really that implements a ingress controller is probably Istio with its Istio gateway. Kong also, they're kind of two products, their ingress and their service mesh offering. But most of the service meshes are really focused on that east to west traffic. From a Calico standpoint, when you look at the access policies in OSM, they're really about service-to-service invocation of those different calls between service-to-service and focused on the application, where you can say Calico is layer 4. So if you just want to do namespace to namespace, like that's really simple within Calico. The thing you don't get is going to be that MTLS. Because Calico doesn't do MTLS in its network policy. So that's where, yes, Open Service Mesh would fit that, where you have a requirement for MTLS. If you want that out of the box, something easy to implement for all your applications, Open Service Mesh fits that perfectly.
Thank you. Thank you. I was not clear when, I think it was mentioned somewhere that Open Service Mesh is based, includes Envoy. So I thought Envoy the ingress.
Well, it does. It uses Envoy for all its proxies, but it doesn't have a native ingress, say, controller that does all like the path-based routing and type stuff.
Understood. Thank you.
All right. What other questions do we have out there? I think we have Will, who has his hand raised.
Yeah, I've got one that's not necessarily related. Well, it's definitely not related to Service Mesh, but we're still kind of green in the Kubernetes and AKS space. We've got several clusters deployed. We've enabled Azure policy for AKS in audit mode. And then we've also deployed Kurid based on the Azure documentation for managing node reboots. And noticed that with my recent upgrade to 1.19.7, that it's getting flagged on a couple policies for privilege and host IPC and ID, process ID. Is Kurid, because it runs as a daemon set, something we should create an exemption for those policies, or should we look at reconfiguring and deploying to get it into compliance?
Yeah, those are always hard alerts to get rid of because almost every customer has some privilege pods in their environment. One of them being Kurid because it's actually looking at the host file system for that reboot flag of Ubuntu. Mm-hmm. And also monitoring tools usually have host-based access. So those are typically, those are like two, a lot of the daemon sets you would be running to, a lot of daemon sets end up having host level access. Because that's why they're running on every host. We'll see like users that want to install additional software or something, they'll use a daemon set. So anytime they scale out, it gets that pod and it installs something. So it has host-based access. So usually create an exemption if you're comfortable with that. I would say in the near future, when automatic node upgrades goes GA, I would definitely implement that. Because Cured can run into some different weirdness, especially if you have like cluster auto scaling and stuff enabled. So definitely look at, I'm not exactly sure when node auto upgrade should be going GA, but I don't think it's too far off. I would definitely look at implementing that over Cured to kind of get rid of Cured. But yes, I would create an exemption for that. Like in any environment, if anybody says they don't have like privileged pods, they do, because even the Kubernetes like kube proxy pod has to have to write IP table rules. It has to have privilege access. So typically you're going to find your environment. You want to minimize them as much as possible, especially in your actual applications. The third-party project or solutions is where that's hard to get away from.
Okay, yeah, that makes sense to me. I just wanted to, I figured this would be a great place to ask before I went and dug in and started doing research and then trying to figure out configuration options when maybe I just don't even need to do that and it should be exempt. So thank you.
Yep, no problem. We have another hand raised. Is it Joa?
Yeah, thanks.
I'm horrible with names, so if I pronounce that right.
No problem, sir. So just following up on an earlier question there, you mentioned that so OSM is not really concerned with south-north traffic, only east-west. I was playing around with OSM a few days ago, and what I noticed is that if I have a simple application, let's say for instance, the Azure Vote All-in-One application that we have in our documentation, that it simply exposes a load balancer service with a public IP. When I enable OSM on this namespace, the traffic actually gets blocked from the outside world. So I'm thinking, so maybe OSM doesn't care about north-south traffic, but it does block it by default.
Yes, it will.
So even with this flag, so even with the policies disabled with the flag that you showed earlier, it will still basically not allow the traffic. Yeah.
Yeah, that's why it doesn't have that native ingress controller, so you have to implement, something like Nginx traffic or something. There's a configuration you have to set to make sure the headers get passed down also, so it acts as part of the mesh. The one thing, I should put a link in here too to the documentation. The documentation for OSM, there's part of it, I would say, like, the Azure documentation has a good bit on enabling it and like a demo application in there, but the actual OSM, the Open Service Mesh website, will have some more detailed information on how it kind of operates, like what the traffic rules are. A lot of that more detailed type documentation is in there. So it's kind of split at the moment, because Open Service Mesh is really, it's not just AKS specific. You can run Open Service Mesh on any other Kubernetes cluster.
Okay, so the bottom line is the only way to access a services from the outside world is with an ingress controller like Nginx or App Gateway or something, right?
Yeah, and how I actually access mine, I did a port forward directly to it.
Right.
So I didn't go through like a load balancer or anything at that point.
Right. Okay, makes sense. Thanks.
All right, what other questions we have? Feel free to come off mute too if I'm missing you or you put anything in the chat window here.
I have a follow-up question on QD versus node image update.
Yes.
So Isn't node image update more like an OS reimaging? And whenever the AKS product group releases like a brand new image, which probably might be weekly or by week every 15 days, it reimages all the nodes with the latest and greatest image. Versus QRD, which is more for like a follow-up action after apt get upgrade.
Yeah, correct. QRD, all it's doing is looking for a reboot flag. So if the host gets a kernel update that needs a reboot, Ubuntu sets a reboot flag. QRD looks at that and says, hey, I see this reboot flag. What's my policy for rebooting these nodes in the cluster? The node image update, we will be delivering new node images weekly. Is going to see, hey, I need a new node image, as there's one released, and it goes through and re-images. So essentially deploys new nodes. Not much different than a cluster upgrade does.
Understood. Thank you.
All right. It looks like we're at. Oh, we have one. We have a couple other questions. I'll stay around for those. We have a couple others. Feel free to come off mute with your questions.
Sure. I have one question about the node upgrade. Actually, I have implemented this queued and it works perfectly fine for the Linux node image, like a node. But I have an use case where I have a couple of Windows containers also, which is running in Windows nodes. So for those, like, what are the best ways to handle for auto upgrade, like similar to queued, which is specifically for Windows Linux? What would be the best thing to handle it for Windows nodes in the AKS cluster?
Right now, I would say there's probably not a good way. That's, GA. The node image one will become available for Windows, I believe. The problem with Windows, though, is like it's very dependent. Like your build of that Windows container is very dependent on the same version of the Windows node you're running. So auto upgrades are not typically that great for that kind of use case.
I mean, like,
so this is something that will get better over time for like built into AKS for Windows. That's the only thing. I know there's not really something in place today, but also I'm not, I know very little on the Windows container side. So this may be something we can follow up with. But I think once like that node image stuff gets integrated for the Windows side of things, that will probably be the best process.
okay, so until then, like it would be better we do manual upgrade or some other way rather than expecting something else similar to queue.
Yeah, correct.
Okay, sure. Thank you.
All right, we are at time today. Thank you for joining. We will have the recording up on our YouTube channel with all the other recordings from previous ones. If you'll be joining the next one, we hold it bi-weekly. The next one, we will have the product group on to talk about the AKS roadmap. And following that one, we'll be doing one on Terraform and automating AKS and managing AKS multi-cluster deployments. So again, thanks for joining. And as always, feel free to reach out with any feedback or comments that you have. Thank you.